So today I have the pleasure to present Alastair and Wilson from the University of Leeds and Monash University. He's a friend, is invited by Christian thanks to the SNF project, Ambition SNF project. And today he will give a talk at the Lugano Philosophy Colloquium talking about testing grounds.
Well, thank you very much, Martha, Christian, and everybody for inviting me and for coming along. I've heard many good things over the years about Lugano and the master program here, and you're excellent at two of my favorite things, metaphysics and philosophy of physics. And this talk is going to include a bit of both of those. It'll probably be more shifted towards the metaphysics, but there'll be some more kind of concrete discussions of applications towards the end, the philosophy of physics and other bits of philosophy of science. And this is the first time I've given this talk. I'm not exactly sure how long it's going to take. Thank you for letting me try it out on you. So I'm going to be talking about grounding, metaphysical explanation, and its relation to science. So grounding is this very popular notion, been theorized a lot about within metaphysics over the last 20 years or so. Goes back into ancient times. But one thing that has not attracted a lot of focus is its relation to science. And I think many of the most kind of interesting and compelling cases of grounding are actually from scientific theories or kind of justified via scientific theories. But there's a real puzzle, I think, about how that's possible. How it's possible for science to give us non-trivial evidence about grounding relations in the world. So I'm going to, first of all, introduce that puzzle, try to make you feel the force of the puzzle, why it's mysterious, and then look at what some people have said about it and kind of put some pieces, some of which are in the literature already, together to give an account of how it is that we can have evidence concerning grounding relations got from science. And one of the consequences will be that grounding is going to be closely related to the concept of reduction, of theory reduction within science. And that suggests that cases where new theory reductions are developed, that is, where science makes kind of a major transition from one theoretical framework to another, those will be cases where new evidence concerning grounding gets obtained. So if you want to kind of look for kind of cases kind of in the real world where we actually did some science and got some evidence concerning the grounding relations in the world, I think these kinds of large-scale theoretical transitions are the place to look. And then I'll go through some of these, assuming there's time, to talk about how they work and what the particular kind of evidence concerning the grounding relations are in each of the cases. So the focus is this notion of metaphysical grounding that has been popularized, especially by people like Kit Fine, and in the kind of tradition that I'm most engaged with, perhaps Jonathan Schaffer and Karen Bennett have been very prominent. And it's meant to be a kind of tool that you use to do metaphysics with. It's meant to enable us to say the kind of things we want to say within metaphysics. So it's kind of envisaged as a key part of the toolkit. But grounding also has this sort of dual life. It's not just a tool. It's not just a kind of part of our method. It's also, at least by some of its proponents, conceived of as a real ingredient of the world. So as well as wanting to kind of tell ourselves about the world by finding out what grounds what within the world, we can also identify ground itself as a component of the world and ask about that. And I think there are some interesting tensions between it having this kind of universal methodological role for formulating debates and also being something that we have a debate about. I think there's a kind of tension there. Maybe we can talk about that later, but I just kind of flag that in order to set it aside. So I'm going to focus on this relation of grounding. There are various complexities. Is it a relation? Should it be expressed as an operator or something like that? that are related to the logic and semantics of this notion. I'm going to not address those here. I hope that the kinds of things I'm going to say are kind of mostly independent of those sorts of debates. So it kind of doesn't matter how exactly we formulate ground. I'm going to talk about it as if it was a relation. And it's a relation, I will say, that kind of is such that when it holds, then there is a distinctive kind of explanation. So if one thing grounds another thing, then we can explain the second thing in terms of the first thing. Where one thing grounds another, there's a special kind of explanation present. And I'm going to talk as if the grounding and the explanation are, strictly speaking, different. The grounding sort of kind of gives rise to or supports an explanation rather than literally being the explanation. And if you're not familiar with this, or even if you are, I kind of advocate thinking about it in terms of something like causation. So it's kind of like causation in that it is conceived of as an ingredient of the world. There really are causings in the world. And causation is a relation that usually connects events or maybe facts. I'm going to talk as if it is a relation between facts here. And I've elsewhere compared the notion of grounding to a kind of metaphysical form of causation and argued that there's this really close analogy between grounding and causation. They can be modeled in the same sorts of ways and they have the same sorts of structures. Even one hypothesis is that there is really just one phenomenon here that kind of manifests as grounding in some places and as causation in others. But I won't dwell on that. I'm going to focus on kind of metaphysical grounding considered in its own right. And I'm going to be mostly focused on the partial ground version of it. Sometimes grounding is such that it kind of does what a sufficient cause does. A ground can be like completely sufficient for the thing it grounds. And sometimes grounds just make a contribution to what they ground. That's analogous to this idea of a contributory cause. So I'll be mostly focusing on the partial version. I think what I say will typically go for the cases of full ground as well, but I think it's important not to kind of assume that I'm always talking about the full ground, always about the sufficient version. Quite often the kinds of explanations I will identify might not be sufficient, might need some extra ingredients in before they're really sufficient. One thing to know about grounding is that it has this connection with necessitation. Not everybody agrees that it does, but it's typically thought that if A grounds B, then necessarily if A and B both obtain, then A grounds B. That at least holds for the cases of full grounding. And the example I'm going to focus on is a little different from the examples that are usually used when people talk about grounding. Quite often people talk about like the grounding of sets in their members or something like that. I'm going to focus on a kind of concrete physical case because that's the kind that I take science to be able to potentially discover. So I'm going to use the example that the heat of a gas is the kind of its temperature, or the fact that it is hot as opposed to cold, is going to be grounded in facts about the molecular motion of the constituent molecules of that gas. So intuitively, it's because the molecules are moving really fast that the gas is really hot. Then when you cool it down, it's because the molecules are now moving really slowly that the gas is now cold. That sort of because doesn't seem to be a causal one in the ordinary sense. The motion doesn't cause the temperature or the heat, but it kind of gives rise to it in this metaphysical explanatory sense. So that's as much as I'm going to say about the notion of grounding. Hopefully most people are on board up to this point. So why is there a puzzle with the epistemology of ground? Why is it difficult to see how we can come to knowledge of these sorts of claims? Well, I'm going to focus on the non-contingency of grounding, the way it's meant to be not a kind of accidental matter, that if the ground holds and the grounded thing holds, a grounded relationship holds between them. It's no accident that when we have molecules moving fast, we have a hot gas, and when we have molecules moving slowly, we have a cold gas. And it's not like it could easily have been the other way around, that fast motion could have given rise to a cold gas and slow motion could have easily given rise to a hot gas. That couldn't easily have been the case. In that sense, grounding is non-contingent. And in general, epistemology is hard when the subject matter is non-contingent. And in practice, accounts of grounding tend to say not very much about the epistemology. There are a few exceptions that I've listed here on the slide and that I'll be talking about in the next few minutes. But this is just a tiny slice of this enormous literature on ground. Far more of it is associated with its kind of logical or metaphysical characteristics and with its kind of relation to other metaphysical notions or particular applications of grounding within a prioristic metaphysics. And where epistemology is discussed, it's often linked to kind of intuitive judgments. So it's meant to be, for example, if a set is grounded in its members, how do we know that the set's grounded in its members? Something like, at least for Kit Fine, it's just intuition that tells us that. It's some kind of faculty of philosophical insight which we just possess. And I think Fine is maybe in a minority these days in thinking that that is a satisfactory story, to call an intuition in those sorts of ways. But I don't really see that there's a kind of really extended account of the epistemology of ground elsewhere. I'd be very interested if people could point me at work that I haven't engaged with on this so far. As I say, this is a project at quite an early stage. This will eventually, hopefully, this paper end up in a volume on the epistemology of ground. But the reason that they're putting together that volume is just because the editors regard it as something that's been understudied up till now. So maybe we can come to know grounding claims a priori. That's certainly what Fine seems to imagine when he talks about coming to be justified in beliefs about grounding through intuition. And certainly it does seem like there's something like a priori knowledge of several non-contingent subject matters. Mathematics is a kind of distinctively and traditionally a priori discipline. Moral judgments are often regarded by philosophers as a priori. Modal judgments, many people think we can kind of move from a priori conceivability to judgments about modality. And mereology, the metaphysics of parts and wholes, again, is often just addressed a priori based on intuitions. But the best way, I think, to understand how it's possible for that sort of a priori knowledge to exist, is that there is some sort of conceptual competence underlying it. So it's because we're competent with the concepts of mass, or because we're competent with the concepts of mereology, that we can have a priori justification concerning them. But that, I take it, is not going to work for metaphysical grounding, at least in full generality, because sometimes grounding holds between things like sets and their members, perhaps. But in a lot of cases, the ones I'm most interested in, the cases in science, it's not the case that we have, we do science by reflecting on our concepts. It's not the case that we come kind of pre-equipped with all the scientific concepts we're ever going to need, kind of as part of our conceptual inventory. It takes hard work to identify the explanatory connections in the scientific worldview. So an a priori approach to the epistemology of grounding in science is at first sight unpromising. And if we did have a priori knowledge of grounding in this full generality, it would have to be then an example of the synthetic a priori in Kant's terms. It's not just a matter of the meanings of the constituent concepts. And synthetic a priori truths are notoriously difficult. And Kant's own sort of account of how we come to synthetic a priori truths is also not obviously going to be applicable here. Even if our cognitive structures might, in the kind of very ambitious Kantian project, tell us about the structure of space and time, I take it they're not going to extend to more specific concrete grounding claims about things like heat. It's just not plausible that it's by kind of reflecting on our own cognitive structure that we come to work out what makes a gas hot or cold. That took substantive science to do. Perhaps there are kind of neo-Kantian approaches here that would somehow manage to square this circle, but I don't regard them as promising. And what I'm going to focus on is a sort of a posteriori route to grounding knowledge. That is, it's only by virtue of doing some empirical investigation can we come to know grounding claims in full generality. That's the idea. And just to note, that would kind of put the grounding claims here into the same category as the sort of Kripkean necessary a posteriori. The kinds of claims that Kripke identifies when he thinks that it is a necessary truth known by doing science that water is H2O, for example, or that gold has atomic number 79. That's kind of about the nature of natural kinds. Grounding is, I think, related to that, but an account of the epistemology of grounding doesn't obviously fall out of Kripke's view, and he doesn't, I think, have a very detailed account of how we come to know these necessary a posteriori claims anyway. He just kind of says we do. So in general, then, I'm going to say it is partly via experience that we come to know grounding claims. But of course, that is just to kind of describe a view. It's not to give a view in detail about how this works. And so the rest of the talk is going to be giving you a more detailed account of how this sort of a posteriori justification could work. And some of the most obvious or kind of familiar approaches to a posteriori justification aren't going to seem to work here. I mean, we don't have kind of perceptual knowledge. We can't kind of see grounding out there in the world. At least certainly not in these cases like heat and molecular motion. We can't just look at a gas and perceive that its heat is grounded in its molecular motion. And it's not just that we can't perceive it, we need a kind of big microscopes or something. It's not clear that we stand in the right causal relations to these grounding claims at all. I mean, maybe some grounding facts can be caused. Maybe, for example, in some cases to do with kind of the criminal law, you might have cases where grounding facts can be caused. For example, if it's kind of my act was wrong because it kind of recklessly, it was reckless, or my act was illegal because it involved kind of taking something that wasn't mine. We can cause laws to come into existence that might play a role in the grounding of why my act was wrong. It might be kind of because of when we bring the law into existence that we make it the case that taking the thing that's not mine makes it the case that I did something illegal. It's the kind of causal effect of the law being passed that grounding fact comes into existence. But I think those will be cases that are kind of quite distinctive, cases where we have contingent grounding laws. And I can talk more about those later. The very idea of contingent grounding is controversial, though, and the kind of standard view is that grounding grounding laws are not contingent. The kind of general principles that kind of drive grounding connections along are not contingent. So this is not going to work in general, that we kind of can causally interact with the grounding facts That's not going to work in general as an account of how we come to know them. So the other option that I'm going to dwell on is going to be a sort of abductive style of argument for the justification of grounding facts. Abduction here meaning something like inference to the best explanation. It's a kind of distinctively explanatory route to grounding knowledge. So I've already kind of said some things to motivate why I don't think the causal approach is going to work. Grounding facts are not the kinds of things that can be causes according to many theories of causation. So I'll just look at a few. There's the theory of causation as a physical process that Phil Dow offers. And there, the kinds of things that can be causes are the kinds of things that can be involved in transfers of a conserved quantity like energy. So it's when one thing transfers some of its energy to another thing that it kind of gets to be a cause of the motion of the latter thing. And grounding facts don't seem to be the kinds of things that can transfer conserved quantities. So they're not candidates for causes or effects on that sort of view. Perhaps a counterfactual account of causation is a little bit more promising. But here we run again into the difficulty of the non-contingency of the grounding relations. We can't kind of twiddle or intervene on the connection between heat and molecular motion. So we can't directly have our experiences depending on what the grounding facts are. Perhaps there's scope for developing the counterfactual approach, but the kind of thought here is that none of the approaches to causation that I've been considering so far is a natural fit for the idea that heat grounds molecular motion could itself be a cause, or itself could be something that, molecular motion grounds heat, could itself be a cause or itself be something that gets caused. It seems like that's how a causal route to knowledge of grounding facts would have to go. This is not decisive at all, but these are kind of reasons for thinking that the causal route is not promising. Perhaps there's a way of making it work. So I'm interested in by this approach to justifying grounding claims via abduction, inference to the best explanation. Sorry, I missed out the references here. That should be Cartwright 1983 and Hacking 1982. There have been some influential philosophers of science, these so-called entity realists, Hacking and Cartwright, that have argued that we still need causal contact even for inference to best explanation to give us justification for the existence of things. So they're talking about unobservable entities like electrons, and they're asking, how is it that we have good reason, have good justification to believe that there are electrons? And what Hacking and Cartwright essentially say is that electrons are meant to play a role in our causal explanations. And it is exactly when a thing plays a role in the causal explanation that that explanation gives us reason to believe in the thing. Hacking has this slogan: if you can spray it, then it's real. And if it can be sprayed at you, then it's real. But that's not gonna, that would just mean that we were back in the same problem as the causal route to knowledge of grounding. The apparent causal inactivity of the grounding facts makes it hard to see how that sort of restrictive account of abductive inference could give us knowledge of grounding. mean, one route would be to say, well, we'll just give up that constraint. We'll say any old explanation can support inference of the best explanation. I don't think that's quite right. So I'm not going to say why, I'm just going to kind of suggest an intermediary view where something like what Hacking and Cartwright here are saying is right, whereby it's not just any old proposed explanation that gives us reason to kind of believe in the reality of the explainers. Rather, it's only kind of candidate kinds of objective explanation. So if it's a kind of an objective matter, it's supposed to be that one thing explains another, then seeing the other thing does give reason to believe in the thing that would objectively explain it if it existed. So the kind of Hacking and Cartwright slogan is a kind of, we have inference to the most probable cause is good, but inference to best explanation in general is not. But what I need is something like a little bit of a generalization of their view. Inference to the most probable objective explainer is a good inference pattern, even if inference to best explanation in full generality is not. So I'm not going to go into more details of this. It might not be obvious kind of why we need this, whether this is even a problem in the first place. Maybe inference to best explanation is just generally fine. But if you are worried about inference to best explanation for these sorts of reasons, then I think it only takes a kind of mild strengthening of what Hacking and Cartwright are proposing to get something that's going to work for knowledge of grounding relations. So Amanda Bryant has done perhaps the most specific, most detailed kind of overview of grounding and science and how grounding can be fitted into the scientific worldview. And she identifies the kind of levels of science. Crudely speaking, we have kind of physics and chemistry and biology, and those form a sort of leveled structure. There's an awful lot of complexity and subtlety there. It's not a kind of linear stack like a ladder. It's probably more realistically like a web. But nonetheless, sciences do seem to form a certain kind of hierarchical structure of a kind. And grounding seems ideal for cashing that out. So chemical phenomena are ultimately grounded in physical phenomena. Biological phenomena are ultimately grounded maybe in chemical phenomena, so that everything, including the mind, is ultimately grounded in the physical. So Bryant kind of says, there's lots of ways in which ground can be useful, can be involved with science. Most of them aren't directly relevant to the epistemology of ground, except for this claim she talks about directly motivated. Science can directly motivate particular grounding claims and metaphysical laws. And that's the kind of thing I'm interested in. How is it possible for science to directly motivate some particular grounding claim? That's the kind of question that I want to address. For time reasons, I'm going to skip this, this process that Robert Audi describes. Bryant argues in her paper, and I tend to agree, that this is not a sufficiently general account. Maybe it will work for grounding amongst certain kinds of natural kind properties, like grounding of kind membership. But even then, I think there's some difficulty with step 5 here. So I'm just going to skip Audi's proposal, but note that Audi has made a proposal about this that I don't think works in full generality, and we can talk about more in the Q&A if you're interested in. What I think is the lead that I'm more inclined to follow up is an idea that comes out of the work of Jonathan Schaffer and Janan Ismail and Jonathan Schaffer in collaboration. This notion of a common ground explanation. So in some cases, it seems like we have certain kinds of correlations which seem to be modally robust. That is, they couldn't have been false. They couldn't have failed to be correlated in a certain way. And when we have these certain kinds of modally robust correlations, those correlations, say Schaffer and Ismail, can justify us in acknowledging a common ground. So consider this kind of supposedly surprising correlation. I became a father a few years ago, and at that very same moment, my parents became grandparents. They didn't have any grandchildren previously. Is it a coincidence this happened at the same time? Not really. If I had become a father 10 minutes later, then my parents would have become grandparents 10 minutes later. And so on. Like, if you kind of adjust my becoming a father, then my parents becoming grandparents kind of gets adjusted in the same sort of way. So there's a modally robust correlation here. And that justifies, if you didn't know anything about it, you might think, well, what's the explanation of why these things are correlated? Well, they're both grounded in the fact that a child was born at that time. So it's a child being born that makes me a father, it's a child being born that makes some grandparents. There's a common ground to those two correlated facts. So any mystery that there might be between how it is that those things happen at the same time and would have happened at the same time even if it had been shifted around a bit, that mystery just completely evaporates when you notice that there's a common ground of the two of them, my daughter being born. And in these sorts of cases, the inference to the existence of that ground isn't just an inference to the existence of that ground as a thing unconnected from the later events. It's an inference to the existence of that ground as a ground. So it's the success of this inference lends support kind of together to the claim that there was some event which was the ground and that that event grounded the other two events. So we get justification for the existence of the ground and its grounding those things simultaneously. We get them together. Like hypotheses about the kind of like some unknown cause, if we have reason to believe that there are electrons causing a pattern on a screen, then we kind of get reason to believe in the electrons and the causing of the pattern by the electrons kind of together as a package. So that, broadly speaking, is the structure that I'm going to be endorsing for knowledge of ground. It's these sorts of common ground inferences that give us reason to believe in specific grounding claims. A recent paper on this sort of material by Giannotti and Kortabarria kind of looks at some examples that I think fit this broad general structure. The way they think this works is that there are certain kinds of explanations, which are in fact grounding explanations, which science identifies, but science doesn't kind of attach a grounding badge to those explanations. It just gives the explanations. Their thought is to regard that as a grounding explanation needs kind of further philosophical analysis, and they then go on to give these philosophical arguments in those cases. And I do think that that's right, that kind of the grounding isn't a term that's commonly used by scientists. It doesn't these explanations don't wear their grounding on the face of it. So when thinking about it, science is going to be like identifying that heat is explained by molecular motion, and then it is a classifying job for metaphysicians to identify that as a grounding explanation, not a causal explanation. So I think what they're doing is part of the story, alongside this common ground approach of Ismail and Schaffer. So the idea then is that scientists discover explanations which are in fact grounding explanations. And one guiding thought for me working on this is that it can't be that that's something that kind of happens kind of by accident without scientists noticing as they're going about their days. If a scientist is kind of, or a scientific community has done a lot of hard work to discover some grounding explanation, they're going to be aware that they've done that, they have explained something in so doing. scientists have sufficient insight into what they're doing, but when they do in fact produce explanations, they're aware they're producing explanations. But I don't think they call them explanations. I think very often the kind of explanations that are relevant here are kind of regarded by scientists under the ground or under the kind of banner of theoretical reduction. At least that's kind of the hypothesis of this talk. So when a scientist is identifying some evidence for some grounding claim, they do that via identifying a successful theoretical reduction. So kind of insofar as we already think that one of the things that scientists do is to try to reduce theories to other theories, that fits with the idea that what they're already doing is discovering grounding explanations, so maybe not under that name. And reduction is a kind of huge topic in philosophy of science. I'm going to use a notion which perhaps is slightly non-standard, perhaps it's even slightly non-standard in a way that helps me in my project here. But I think this is like the right account of reduction independently. So I can kind of defend that. I don't think this is an ad hoc move. I think this is a good account of what theory reduction is about and why it's important. I'm going to say that theory A gets reduced to theory B. Oh, sorry, there's a typo here. Just when we can use theory B to explain the effectiveness of theory A. So the theory that, I mean, philosophers and scientists actually tend to use the word reduced in a kind of back to front way. Physicists at least use reduce in the kind of inverted way from here. A theory reduces to another theory. But the idea here is that the reduced theory is the higher level theory. The reducing theory is the theory which, the lower level theory, which we can account for the effectiveness of the higher level theory using. And then the claim I want to make is that when we have a successful theoretical reduction, then the correlations described by the higher theory are given a common ground explanation in terms of features that are described by the underlying more fundamental theory. That's the idea. So I do need to say a little bit more about reduction. I want to distinguish two kinds of reduction: horizontal reduction and vertical reduction. So horizontal reduction is kind of broadly speaking across time as our theories get better. So the idea is that like a new theory might provide a reduction of the old theory. The old theory can be reduced to the new theory. And this is the way that a lot of the philosophy of science literature on reduction addresses the problem. But there's also another kind of reduction, which is a kind of meant to hold at a specific time, not to be a process that kind of unfolds over time. The idea that we can explain the behavior of a given system simultaneously in terms of the higher level theory, and we can explain it in terms of the lower level, more fundamental theory. And reduction occurs just when the more fundamental theory can explain the effectiveness of the higher level theory in describing that very same system right now. And here, kind of consider the way we still use something like classical mechanics when we're planning satellite launches, and when we're kind of like designing artillery or something. We still use basic classical ballistics to work that out. We don't need to deal with any relativistic corrections. So even though in some sense we think that the theory of relativity is true, we don't need it to solve a certain class of problems. But we think that the underlying true theory of special relativity can help us explain why the high level theory of classical ballistics works so well in the domain that it works well in. And that gives us the assurance that it's safe to use. And it's this notion of vertical reduction, a kind of reduction that holds like between kind of two different levels of analysis of a specific system, that is the one that I think can be used directly in helping us to infer grounding facts. And don't worry that we're going to be stuck only with horizontal reductions when what we need is vertical reductions, because there is a procedure to convert them, to convert a horizontal reduction into a vertical reduction. And this is something that my colleague Katie Robertson and I developed in a recent paper, a process that we call verticalization, where you kind of take a case in which a new theory comes along and explains the historical success of the old theory, and flip that horizontal relation between theories into a vertical one between two different descriptions of a given system at a given time offered by those two different theories. Verticalization involves these two steps, we're calling the restriction step and the abstraction step. First, we have to restrict the old theory so it only applies within a certain domain, because we don't think that classical mechanics is correct for things moving close to the speed of light. So we shouldn't use it everywhere. We should only use it where it's safe to use it, things moving very slow compared to the speed of light. And secondly, there's an abstraction step. Once we take the kind of old theory in its restricted application and the new theory in that domain, we show how the higher level theory is describing the system in a more coarse-grained way, in a more abstract way, in a higher level way, in a way which leaves out some details. Now, I can't go any more into the this process of verticalization for time reasons. I will kind of I'm happy to ask questions about it in Q&A. And the details are in this paper that's coming out in BJPS. It's already online. But it's these vertical reductions which we either kind of take ourselves to get straight out of science or to be got via the process of verticalizing a horizontal reduction, which we get straight out of science. It's these vertical reductions which are kind of like the raw material I want to use to explain how we can come to knowledge of grounding. So here's the strategy in general. First of all, find cases where a new theory explains all the successes of its predecessor theory and then some. So a new theory comes along that explains why the old theory worked when it did, but also explains why the new theory doesn't work when it doesn't. So the new theory strictly improves on the old theory. And I take it that that's kind of the case with special relativity and classical mechanics, for example, and in other examples of kind of classic reductions in science. So we take that sort of historical process of the old theory having its success explained by the new theory and verticalize. So turn that into an account of a given system in kind of terms of the old theory and in terms of the new theory, and regard those as like different levels of abstraction, different degrees of detail of description of what's going on with that system given by the different theories. And then we have a vertical reduction. Given the way I characterize reduction, what it's doing is explaining the success of the higher level theory in terms of the underlying better theory, well, more fundamental theory. And in general, that's a kind of objective explanation which can support inference to the best explanation. So then we can do step 4, which is to make an inference step to infer kind of jointly to the existence of the objective explainer and the holding of the relation of explanation between it and the thing you want explained. And it's at that stage that we're inferring the holding of a grounding relation. It remains only to kind of confirm that that really is a grounding relation using whatever metaphysical criteria for classifying it as ground that you like, but you know, with luck, it will fit the bill. So we start with a theory reduction in science of an old theory getting replaced by a better theory and having its success explained by the better theory. And we turn that into 2 different levels of description of a single system. And then we take those 2 levels of description in a single system, the explanatory relation that holds between them to identify the grounding relation that corresponds to it. So that's the kind of picture in the abstract, and it's quite abstract so far. It probably needs to be kind of put into concrete examples to get a sense of how this works. Luckily, I think there's lots of concrete examples, because every major theoretical transition in science is associated with something like horizontal reduction, not necessarily like a very quantitative, precise horizontal reduction, but nonetheless, at least a kind of horizontal reduction in the sense of one theory kind of explaining why the other theory was useful. We get these sorts of horizontal reductions whenever there's a major theory change in science. So I'm going to talk about a selection, I think there's 7 or 8 of them, and kind of show how this abstract structure that I just described here is going to play out in those sorts of cases. So here are the kind of some pictures of the kinds of transitions I have in mind. Classical to quantum theory, fluid theory of heat to kinetic theory of heat, evolutionary biology taking over, understanding chemical properties in terms of atomic orbitals, continental drift, and special and general relativity supplanting the previous theories. So start with a kind of real old chestnut, the replacement of the geocentric view of the world, of the universe, with the heliocentric view. The move from thinking the Earth was at the center of the universe to thinking the Sun was at the center of the universe. The Sun's not at the center of the universe, but we're kind of getting closer, but when we start to think that it is. Here the horizontal reduction is when we can, Copernicus could, kind of produce the heliocentric model and show that it accounts for all of the same sorts of motions the geocentric model could account for. Actually, there were some complications, and at least initially, it doesn't seem that that is true, that the heliocentric model accounted for everything the geocentric model could account for. It had lots of practice developing the geocentric model by that point. But set that aside, in the kind of the abstract is how the case is structured. And so when we move that to a vertical reduction, we have a relation between 2 different descriptions of the actual solar system. So take Earth as the fixed reference frame and consider the motions of the planets in that frame. And then consider the frame with the Sun as a fixed reference point, consider the motion of the planets regarding that. You can explain one in terms of the other. So in this case, the evidence, the grounding, that's kind of the distinctive evidence that we didn't have before, are the fact that we can explain patterns in the planetary motions that weren't well explained by the geocentric model, like retrograde motions of planets. We can explain that in terms of the new, underlying theory. So basically, it's the retrograde motions of planets that turn out to be at least part of our evidence for grounding. I think that's not necessarily the clearest example. Here's the example I've been working with throughout. I think this is one of the clearest examples. There were some successes of the fluid model of heat. It explained why if you put a hot thing next to a cold thing, they end up at the same temperature. It's like some of the heat fluid flows from one into the other. But all of that can be explained by the kinetic theory of gases that sees them as made up of molecules. And the kinetic theory of gases explains a lot more as well. So again, we have this horizontal reduction, the kind of replacement of the fluid theory by the kinetic theory. And then we have kind of the thermodynamic behavior of the gases explained in terms of motion of constituent molecules. That's our kind of vertical reduction we end up with. And then the evidence for grounding that's kind of distinctive here again, it's going to correlate, it's going to correspond to things that were unexplained in the fluid model, but are explained in the new model. And I think evaporation is an example. So it turns out that the fact that liquid evaporates actually is part of our evidence for the fact that heat is grounded in molecular motion. Evolutionary biology. There were, again, some successes of pre-evolutionary biology. Well, the fact that species can't in general, I mean, sometimes can, but like usually they can't interbreed with one another, and that species tend to persist over time, absent extinction. Those things need to be explained by evolution. They are explained in terms of the evolutionary theory, in terms of the very slow speed of natural selection, for example. It's because natural selection doesn't happen overnight that we don't tend to see one species turning into another in front of our eyes. Sometimes we do, but usually we don't. So then again, the evidence for the grounding of like the high level theory that corresponds to the theory that species don't change with the lower level theory that corresponds to the theory that they evolve through natural selection is the evidence that is explained by the evolutionary theory, but not by the prior theory. So in this case, it would be fossils of intermediary species and the few cases where we really have observed speciation occurring. These cases are now, I think, kind of start to become cleaner. These are the kind of classical cases of reduction that physicists have been talking about for a long time. And these are maybe the neatest cases. We have classical physics, which, as I said, is still a very successful theory. We still use it to launch satellites and design artillery, do other things maybe more peaceful. But that can also, those things can also be explained in terms of special relativity. The explanation is just a bit more complicated. We could, if we wanted, have designed the artillery using special relativity. We just would have had a whole load of terms in our equations that weren't really doing much. And the vertical reduction here is that we can explain why the classical description works well in terms of the underlying special relativity description, explains why the classical description works well when it does, i.e. when v squared over c squared is low, and why it works badly when that quantity is higher. Then we really do need to take into account special relativistic effects. And here, again, the evidence for grounding of like the classical motions in terms of the special relativistic motions is going to be the kinds of things we can explain in terms of the relativistic theory we couldn't explain in terms of the classical theory. Why there are so many cosmic ray muons hitting the ground rather than all decaying halfway up, it's because of time dilation. The pattern kind of continues this way, where we have special relativity being kind of accounted for as like kind of locally valid in general relativistic spacetimes where the curvature is not too intense. Again, the evidence for grounding here is going to be the discrepancies that we can't explain with special relativity, but we can explain with general relativity. Such as the fact that as clocks go further from the Earth's surface, they tick at a slightly different rate. So that's not just because they're moving faster, it's because of the gravitational effect being weaker. And GPS satellites have to account for this. They have to account for the special relativistic and the general relativistic connection separately. Classical physics to quantum physics. This is an interesting case because it's not clear that this really is a reduction in the ordinary sense at all. Matthias Egg has a paper arguing that we can regard classical descriptions as grounded in quantum description as emergent from them. But that is controversial, and it's quite sensitive to the interpretation of quantum mechanics we're using. And again here, the evidence for grounding is going to be the stuff, if there is a grounding relation here, the evidence for it is going to be in things that we could explain with quantum theory, but not in the classical theory, double slit fringes formed by electrons, for example. This case is, again, I think, quite a clean case. The explanation of the periodic table and the regularities between different elements in the same column in terms of atomic physics. So it was the thing noted that the kind of similarities between different elements spaced at regular intervals that led to the construction of the periodic table of the elements in the first instance. But that was not... it wasn't understood why the elements were organized like that. We only come to a really good account of how why the elements are ordered like that and show the similarities they do once we understand the structure of atomic orbitals and the way that once you add certain numbers of electrons, you need to kind of have new orbitals, and then they are different orbitals, and kind of the electrons in them are easier or harder to remove. And again, if you take it that the periodic table description is grounded in the underlying atomic physics description, then the evidence for that grounding relation is going to be the kind of behavior of the elements that is not explainable in terms of the periodic table. And I think, though I'm not a chemist, I think that how much energy it takes to ionize a thing is something you can calculate based on orbitals, but is not straightforwardly kind of extractable just from the periodic table. And last example, just to show that these don't have to be kind of like highly theoretical cases, the case of continental drift. So it was only in like 1950, astonishingly recently, that the theory of continental drift was finally became really thoroughly confirmed. And that's because the view that the continents didn't move had a lot going for it. We don't ever observe them moving. Good explanation of why we don't observe them moving around is because it would be if they don't move around. So there were predicted successes of the fixed continents model, which the continental drift model can explain. It explains why we don't see the continents moving much, because the movement is really, really slow. And why is it slow? That can be explained in terms of the kind of underlying magna flow, the mass of the continents, friction at the edges, that sort of thing. So once more, ultimately the evidence for a grounding relationship here is going to be in terms of the things that we couldn't explain using the fixed continent theory. These are the facts that the continents kind of are shaped in such a way they fit together like a jigsaw puzzle. That was just coincidence on the old theory, but it gets explained in the drift theory. And the fact that kind of different kinds of geological formations are found in ways that did once line up but no longer do, having moved apart, that also can be explained using continental drift. And so, again, the upshot is going to be that it's that discerning evidence which the more fundamental theory explains, but which the less fundamental theory fails to explain. That evidence can be co-opted as evidence of a grounding relationship in play. These were the examples. I won't say more about them now because I'm running over time, but feel free to ask me about the examples. They may not always look like cases of grounding to you. It might seem to you that like the higher level theory is simply false. rather than getting grounded. So I can definitely talk about that in Q&A. But the short answer is that, as I'm regarding them, these higher level theories are actually still true within the very restricted domain and to a certain level of abstraction. So wrap up. Generally speaking, I'm endorsing a posteriori abductive approach to the epistemology of grounding, at least in scientific cases. How does it work? Well, we spot these modally robust correlations, and through scientific investigation and theorizing, we identify potential common ground explanations for them. Where we have a good common ground explanation, we're justified in inferring simultaneously to the existence of the common ground and to the fact that it grounds the grounded thing. And this sort of pattern, I think, is at work in these cases of major theoretical transitions in science, where we move from an old theory to a new one that explains strictly more. And I'm done. Thank you very much.